Welcome. This video introduces Tesla's adaptive headlights, which dynamically adjust beam patterns to improve visibility and safety. Adaptive headlights work by using sensors to detect traffic and road conditions, then adjusting the light pattern accordingly. These headlights are available on Tesla models like the Model 3, Model Y, Model S, and Model X. Matrix LED headlights provide precise control over individual LEDs for better illumination compared to standard lights that use fixed beams. Tesla's adaptive headlights are usually enabled by default in auto mode. Here's how to manually check or adjust the settings. First, open the touchscreen. Next, navigate to Controls, then Vehicle, then Lights. Then toggle adaptive headlights to on if it's not already enabled. You can also select beam preferences like high beam assist or auto high beams. Note, base Model 3 and Model Y trims might not have this feature. Matrix LED headlights, like Tesla's adaptive system, use a grid of individually controlled LEDs. This allows for precise beam shaping to maximize road illumination while creating dark spots to avoid glare for other drivers. In contrast, standard lights use fixed beams that provide uniform illumination across the road. While this offers consistent lighting, it lacks the dynamic adjustment capabilities of Matrix LED systems. Matrix LED adaptive headlights provide several key benefits that enhance driving safety and efficiency. One major benefit is enhanced nighttime visibility, potentially up to 50% more effective than traditional headlights. This allows drivers to see farther and more clearly in low-light conditions. These headlights significantly reduce glare for oncoming traffic by creating dark spots where needed, improving safety for all road users. Matrix LED systems are compliant with UNECE regulations, ensuring they meet international safety standards for adaptive lighting. They improve overall safety by reducing nighttime accidents, with studies showing a 10 to 15% decrease in multi-vehicle incidents. Additionally, they are more power efficient, using about 20 to 30% less energy than traditional systems, which aligns with electric vehicle efficiency goals. Tesla's adaptive headlights use advanced sensors to detect the driving environment. Cameras capture visual information, radar measures distances to objects, and LiDAR creates detailed 3D maps using laser pulses. These sensors continuously monitor for oncoming traffic, pedestrians, and changing road conditions. When an object is detected, the system analyzes its position and movement. The headlight system modulates its LED beams in response. Individual LEDs can be dimmed, or the entire unit can pivot to create optimal illumination patterns. For example, when an oncoming vehicle is detected at 50 meters, the system creates dark spots in the beam pattern to avoid blinding the other driver while maintaining road visibility. As the vehicle gets closer, the adjustment increases to 90%, ensuring safety without compromising your own visibility. This happens automatically for optimal driving conditions. These sensors, including radar and LiDAR systems, work together to provide comprehensive environmental awareness, similar to advanced sensing in autonomous vehicles. The result is precise beam control that illuminates the road effectively while protecting other drivers from glare, providing safer nighttime driving conditions. Tesla Model S owners with the 2024 refresh consistently report enhanced night driving experiences in rural areas. The adaptive headlights automatically adjust to prevent blinding oncoming trucks while effectively illuminating potholes and other road hazards. In highway tests, this system provides a 25% boost in visibility compared to standard beams. In urban environments, Tesla Model Y drivers experience significant benefits from adaptive headlights. The system reduces glare during city traffic interactions, leading to fewer complaints from other drivers and enhanced safety. Sensor measurements show up to 40% reduction in glare levels, making nighttime urban driving more comfortable and secure. The trend towards adaptive lighting is accelerating across the automotive industry. Expect fully autonomous vehicles to use AI-optimized lights for pedestrian detection and weather adaptation, such as piercing fog or adjusting for rain. Tesla may expand adaptive features to all models, potentially via retrofits or software updates. The industry is also moving towards laser-assisted matrix LEDs for even longer range, up to 1,500 meters. Thanks for watching.